Hello and welcome to this video about resistance. Resistance basically describes how easy it is for electrons to flow through a wire. So resistance can be anything in a circuit that restricts the flow of electrons. So it could be something like a lamp or a motor or simply the wire itself restricting the flow of electrons through a circuit. Resistance is measured in ohms, which has this symbol here. You might see it as ohms. And you can measure resistance using a multimeter, or you can work out the resistance of a component using the equation V equals I times R, because voltage, current and resistance are all linked together. And I'll cover this equation in another video. So let's look here into a wire in a little bit more detail on what's going on, and it will help us understand the things that affect resistance. So in the metal wire, this diagram is just going to show the fact that you've got positive metal ions in the wire. And don't forget, because they're a solid, you've got a regular formation of these ions. And through that you will have electrons that are free to move throughout. And if these electrons are flowing, you've got a current through the wire. But as the electrons are moving, they will be colliding with these ions and perhaps colliding down here and trying to get through the wire. And the more resistance that you've got, the less current is able to flow through. So the higher the resistance, the less current, which we call as I, can flow through the wire. So how I'd like you to think about resistance through a wire is to think of a corridor in your school and to think of people standing still in that corridor as these metal ions. Okay, so a corridor, a long corridor that you've got in your school, and people standing still as these metal ions, and then you are the electron that is trying to flow through and walk through past all of those people to your classroom over here, for example, that you want to go into. So if you think of this kind of model, it will help you understand the factors affecting the resistance in a wire. And there's three that I want to talk about. The first one is the thickness of the wire. Second one is the length of the wire. And the third one is the temperature of the wire. So first of all, the thickness of the wire. If you increase the thickness, you decrease the resistance. And if you remember this kind of model as this being your corridor, that might help you out, because you can think about it, if you increase the width of your corridor, it'll be easier for you to get through and get to your classroom where you need to. In a similar way, if you increase the width of the wire or the cross-sectional area, so if I were to draw just the cross-section of the wire, this would be a thin wire, this would be a much thicker wire, then it will be easier for you to get through. So you might see it in an exam as the cross-sectional area, which just means if you cut through the wire, the area of this bit. So the thickness or the cross-sectional area of your wire, if you increase that, you will decrease the resistance. Secondly then, the length of the wire. If you increase the length of the wire, you increase the resistance. So if you think of this corridor model again, if you are trying to get through to your classroom, then if you increase the length of the corridor that you've got to go down, then it's more likely you're going to get slowed down by colliding with more of these people on the way. In a similar way, if you increase the length of the wire, the electron flowing through will make more collisions with these ions, and it will be more difficult for it to get to the end. So if you increase the length, you're actually increasing the resistance of the wire. Lastly, temperature. If you increase the temperature, you increase the resistance. And you can think about this in this corridor model again. Imagine all of these ions here, they will be vibrating slightly because they are a solid, so they're moving slightly on the spot. And if it's cold, they they wouldn't be vibrating very much, so it'd be quite easy for these electrons to move through the wire. Similarly, if you think about these as people in our model, then these people wouldn't be moving very much at all, and you would be able to get through really easily to your classroom. However, if you increase the temperature, these ions are going to vibrate more, and therefore the electrons are going to collide more often with these ions, and these are going to be more difficult to move through. Similarly, if you think about it as the corridor model, you can imagine now you're trying to get through to your classroom, and these people in the way are starting to move around a lot more. You're going to find it a lot more difficult to get through to your classroom. So if you increase the temperature, you increase the resistance. So that's all you need to know about resistance in a wire. We'll come across resistance again when we talk about this equation in another video. You need to remember how these things affect the resistance, and if you remember that model of people standing on a corridor and you trying to get through to your classroom, that might help you in your exam. So thanks very much for watching. If you found it useful, please press the like button and feel free to subscribe.